Today we're going to learn how to identify what we call proportional relationships. So you should be on page 18 in your notes packet. A proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other quantity is constant. That means it changes at the same rate every time. A proportion can be written as an equation in the form y equals k times x, where k represents the constant of proportionality. So what this means is we can write something in the form y equals maybe 4 times x. And in this case, 4 would represent our constant of proportionality. The graph of a proportional relationship is always a straight line that passes through the origin, which is where your graph is at 0, 0. So if it's a proportional relationship, it has to be a straight line and it has to pass through the origin. So it has to do both of those things. So let's look at these. We are going to determine whether each relationship shown is proportional. And if it is proportional, we're going to find the constant of proportionality. So let's look at these first three equations. The first one says y equals 12x. Well, it's in the form y equals a number times x, which means that yes, this is proportional. If it's proportional, then we have to find the constant of proportionality, also called k. Well, that is the number that's being multiplied by x. So in this case, the number being multiplied by x is 12. So our constant of proportionality is 12. Our next equation says y equals 6x plus 1. Now we see that we do have a number being multiplied by x, but because of this plus 1, that tells us that actually this would not go through the origin. Because of that, this is not a proportional relationship. Next, we see y equals negative 0.75x. Well, this is a proportional relationship because we see that we have a number, which is negative 0.75, multiplying by x, and it's not being added or subtracted by anything. So the constant of proportionality is that number being multiplied, so it's negative 0.75. Now, in a table, we would find out a ratio for each of these to figure out if they are proportional to each other. What that means is that I'm going to take all of them, and you can't just do a few, you have to do every single set that's in your table. So I would start with 1 to 60, and if this is a proportional relationship, then that's going to be the same as 2 to 120, and that will be the same as 3 to 180, and all of that will be the same as 4 to 240. Now, you cannot compare these the way that they are written. To compare these, you're going to have to make sure that you are writing these in simplest form. Well, 1 to 60 is already in simplest form, so we can just rewrite that. But 2 over 120 can be simplified. Both of these can be divided by 2. 2 divided by 2 will give me 1, and 120 divided by 2 will give me 60. For 3 over 180, I see that that can also be simplified. I can divide both of these by 3. So 3 divided by 3 is 1, and 180 divided by 3 is 60. For the last one, 4 over 240, I see that both of those can be divided by 4. 4 divided by 4 is 1, and 240 divided by 4 is 60. Well, what you'll notice here is that I have ratios that are all in simplest form, and they are all congruent to each other or equal to each other. Because of that, I know that this is a proportional relationship. And to find the constant of proportionality, I'm going to ask myself, what did I multiply this value, so the top value, what did I multiply each of these numbers by to get the number below it? Well, to get from 1 to 60, I would multiply by 60 because 1 times 60 equals 60. 2 times 60 equals 120. 3 times 60 equals 180. And 4 times 60 equals 240. So that means that the number being multiplied by x is 60. All right, in this graph, you see that we have some points here. But in order for this to be a proportional relationship, all we need to know is my graph a straight line? And if I look, I see that yes, we do have a straight line. And also, does it go through the origin? Well, remember the origin is where we have 0, 0. So when I look at this line, it does look like it stops right here and it hits this 0, 0. So I would say that yes, this is proportional. And I'm going to say because it's a straight line, and I'm going to say it is a straight line that passes through the origin. Now let's look at our next set of equations. This equation says x equals 12. Well, that's not in the form that we need. In order for an equation to be a proportional relationship, it needs to be in the form y equals, so it needs to start with y, and it needs to be a number times x. This is x equals instead of y equals, and then it's not a number being multiplied by anything else. So I would say that no, this is not a proportional relationship. For y equals 1/4 x, I see that 1/4 is multiplied by x, and that's the only thing that's happening here. So we know that yes, this is a proportional relationship. And since it's a proportional relationship, the constant of proportionality is the number being multiplied by x. So the number multiplied by x here is 1/4. Then we have y equals negative 3x minus 4. Well, we have y equals, and then it's negative 3 times x. But then because of this minus 4 right here, that makes it no longer a proportional relationship. So this is not a proportional relationship. Now in our table, we need to compare all of these together. So we have 1 being compared to 8. Then we have 2 compared to 20. 3 compared to 32. And finally, 4 compared to 44. Well, when I look at these, 1 to 8 cannot be simplified, so I would leave it like that. 2 over 20 can be simplified. Both of those can be divided by 2. 2 divided by 2 is 1, and 20 divided by 2 is 10. Well, when I look at 3 and 32, those two do not have any factors in common, so that cannot be simplified. So that one's going to remain 3 over 32. Our last one is 4 over 44. Well, both of these numbers are divisible by 4, so we can divide 4 by 4, which would give us 1, and we can divide 44 by 4, which would give us 11. Now, what you'll notice here is that we don't have all 4 of these being congruent or equal to each other. In fact, none of these simplified equations are equal to each other. So because of that, we would say that no, this is not a proportional relationship. For our graph, we're comparing sports drinks, so the number of cups of sports drinks you and the weight. So if I look at this, I see that I have a straight line. So part of being a proportional relationship is that it must be a straight line. But the other part is that it must pass through the origin. Well, the origin is right here. And we notice that this line passes through up here. Well, that is not the origin. So because of this, we are going to say that no, this is not a proportional relationship because even though it is a straight line, it does not go through the origin. Next, we see y equals negative 15x. Well, in this case, we are multiplying negative 15 times x. So we say that yes, this is a proportional relationship and that our constant of proportionality is negative 15. For this equation, y equals x, it looks strange. In order for it to be a proportional relationship, there needs to be a number being multiplied by x. Well, even though we don't see anything, remember there is an invisible 1 here. So actually, y is equal to 1 times x, which means that yes, this is a proportional relationship, and the constant of proportionality is that invisible 1. This one says y equals 4x minus 9. So we see that 4 is being multiplied by x, but then we also see this minus 9 right here. Because we have this minus 9, that makes this no longer a proportional relationship. Now for our next table, we see hours being compared to money. Well, if we start with this 0 to 0, we know that that means that in a graph, it would pass through the origin. So all we need to compare now are the rest of these. So I'm going to start with 1 to 9, and I need to see if that's equal to the rest. Well, then I have 2 to 18, and then 3 to 27, and then I have 4 to 36. Well, 1 over 9 cannot be simplified, so I'm going to rewrite that. But 2 over 18 can be. Both of these can be divided by 2. 2 divided by 2 is 1, and 18 divided by 2 is 9. Next, I have 3 over 27. Well, 3 divided by 3 is 1, and 27 divided by 3 is 9. And finally, I have 4 over 36. Well, both of these can be divided by 4. 4 divided by 4 is 1, and 36 divided by 4 is 9. So in this case, since all of these are congruent or equal, then yes, this is a proportional relationship. And the constant of proportionality is going to be this number that is being multiplied. Every time I would take this number, so over here, 1, and I would multiply by 9. 1 times 9 gives me 9. 2 times 9 gives me 18. 3 times 9 gives me 27. And 4 times 9 gives me 36. So because of that, my constant of proportionality here is 9. In this problem, you have a graph, and you see that we have a straight line, and we see that it also goes through the origin. So we would say that yes, this is a proportional relationship. The last thing we're going to do is create a table, equation, and graph to represent the situation. This situation says that Dakota earns $8 an hour at his part-time job. Well, that means that we're comparing the number of hours that Dakota works to the amount of money that he earns. Well, if Dakota works 0 hours, then we know he's going to earn $0. If Dakota works 1 hour, he's going to earn $8. If Dakota works 2 hours, then now he's earning 8 times 2, which is 16. Fill out the rest of this. If Dakota works 4 hours, he's going to earn $32. And if Dakota works 6 hours, he's going to earn $48. So An equation that represents this is that y equals, because with an equation, we should always start with y equals, and then it needs to be a number times x. Well, in a table, you need to know that this value, the first value in your table, is always your x value, and your second value is always y. Well, when I look at my table, I see that every time I'm going to take my x value, so I have 1 here, and I would multiply by 8. So 1 times 8 gives me 8. Then 2 times 8 is 16. 4 times 8 is 32. 6 times 8 is 48. So what we're doing is multiplying by 8 every time. So we're taking x and multiplying by 8. So the equation is y equals 8x. We can show this on our graph by looking at our hours, because hours were our x values, and then comparing that to the amount of money earned, because that was our y value. Well, we're going to put our hours down here, 1, 2, 3, 4, 5, 6, and then it goes up to 8 here. But when I look at my money earned, it goes up to $48. Well, I do not have 48 spaces on this grid. So I'm going to skip count. So because this was earning $8 an hour, I'm going to count by eights. So I'm going to say 8 followed by 16, then 24, 32, 40, 48, and 56. Now, I did not put anything here because remember, this represents our origin. So this is 0 for both money earned and for hours. Well, when we think about Dakota and we look at the table, our first value is that 0 hours earned $0. So that goes right here. Then 1 hour earned $8. So I'm going to go to 1 hour and then up to $8. 2 hours earned $16. So I'll go to 2 hours and then to $16. Then we skipped a little bit and went to 4 hours. Well, 4 hours earned $32. So I'm going to go up, I'm going to go right to 4 hours, and then I'm going to go up to $32. Then I have 6 hours for $48. So I'm going to go to 6 hours and then up to $48. Well, if I connected these, I see that this is a straight line and it goes through the origin right here at 0, 0. So I do know that this is a proportional relationship. And I could have told by the graph, because it's a straight line that goes through the origin. I also could have been able to tell from the equation because it's y equals 8 times x. Or I could have been able to tell from the table because all of these are proportional. So this is a proportional relationship, and our constant of proportionality here is 8.